Good morning, everyone. My name is SUMAN Singh, and today I'm going to teach chemistry. Okay. So when we talk about chemistry, it is basically divided into three branches, which we can see here: physical chemistry, inorganic chemistry, and organic chemistry. Okay. So now today we will see the first chapter of inorganic chemistry, class 11, which is structure of atom or atomic structure. Okay, I hope all of you have some basic idea about the atom. What is this atom and what is the basic units of this atom, that like electron, proton, neutron, and all this thing we know, right? But now in this chapter we will see the detail. We will see in detail, okay, what is this atoms are made up of, and what was the development which has been done to know the structure of this atom. Okay, so we will start with the first and basic unit, which is called matter. What is matter? Anything which occupies space and has a mass is called matter. So how this matter is made up of? So this matter is made up of smallest unit, means a small unit, which is called atom. Just like in the case of the example here. What example we can say? Suppose this is a wall. Okay, this is a wall, and this wall is made up of small bricks, just like this. Okay, just like this. So this, suppose if we will assume that this is a matter, then the smallest unit is what? This one. This is called atom. Means what? The smallest particle of matter is called atom. Okay, so regarding this, so many scientists has given so many ideas about these atoms, different ideas. So one by one we will see that. Okay, the first idea was given by John Dalton. Okay, so what he says, or we can say that what are the postulates of John Dalton? He says, number one, atom is the smallest particles of any matter. Okay, first thing. Number two, what he says, atoms cannot be divided. Okay, these are the two main postulates. After that, what he says, atoms of same element are same. And number four, atoms of different elements are different. Okay, atom is the smallest particle of any matter. Atom cannot be divided. Atoms of same element are same, and atom of different element are different. So we can take one example here regarding this. He says that if we are taking this hydrogen, and with we are taking this hydrogen. So when we talk about these two hydrogen are same in each and every respect. We can say that in terms of chemical property, in terms of physical property, in terms of atoms, everything is same. Now then the next, what he says, if there is a sodium and there is a lithium. The atoms of this sodium and lithium are entirely different. Okay. Now next, he says atoms of same element combine to form molecules. Just like example H2, O2, Cl2, etc. Okay. Number 6. What he says, atoms of different elements combine in a whole number ratio to form compound. Just like example, you can take the example like H2O, HCl, NaCl, KCl, all are this what? CO2, CO. These are what? These are example of compound. So these are some of the basic postulates given by John Dalton regarding the structure of atom. So side by side, in India, one Indian scientist named Kannad Rishi. Okay, he was also a scientist, and what he says here Dalton has said, means whatever the postulates he has given in Sanskrit. Okay, so what he says, in just like the Dalton has says, atom is the smallest particle of any matter. What Mahasi Kannad has said, Pramanu. Pramanu is the smallest unit of matter. Okay, what we can say that? So, smallest particle of any matter is Pramanu. Okay, and everything is same. Pramanu cannot be divided. Pramanu of same element are same. Pramanu of different element are different. And here some changes will be here. Pramanu of same element combined together to form not molecules. Here he has given name Anu. Okay, like this, and everything is same. So this was some of the basic idea given by John Dalton regarding the structure of atom. Okay, regarding the structure of atom. Now, this postulates, whatever it is given by John Dalton, after some times this postulates has failed. This postulate has completely failed. How it has failed? Now we will see this. One of the scientists named Sir J. Thomson. He has done one experiment on this, and his experiment has shown that whatever the postulates which is given by John Dalton, on that postulate some of the things which he has told about the atom is not true. Okay, so how we will see. Now, He has done an experiment which is called cathode ray experiment. Cathode ray experiment. In cathode ray experiment, you can see he has used one tube like this. Okay. He has used one tube like this. Here he has used vacuum pump, or you can say that vacuum pump, you can say. It is used here, vacuum pump, and one electrode here and one electrode here, and these two electrode he has connected with the battery like this. This is the key, or we can say the switch, and he has connected like this. Okay, so here voltage was very high. Okay, here voltage, what he has taken, voltage was very high, about, we can say, just like 10,000 volt. Okay, now what he observed is, when he connected this key to the main here, when he has connected this to here, he shows nothing. There was blank, nothing was there. What he has done, he has started to reduce the pressure. Okay, he started to reduce the pressure with this vacuum pump. So first of all he has seen 0.01 atm. He has done the pressure just like this, 0.01 atm. So after doing this, he has seen some movement here. He has seen some movement, but exactly not, but he has seen some movement here when he has reduced the pressure. So what he has done finally, he has further reduced the pressure to 10 to the power minus 6 atm. Okay, so what he observed, a light is coming out from this side to this side, just like this, and this side he has given the name cathode, and this side he has given the name anode. Okay, one light was coming out from here to this side. And since if it will depend on the color of it has been said that it casts fluorescent light when it strike the wall of this tube. This tube was green. If this tube is green, then it will cast a shadow of fluorescent light. It will produce a light. So John Dalton has become more curious to see that what exactly is that light. So one thing you keep in mind, that he has used here, whatever the gases he has used here, that gases are very light gases. Okay, lighter gases, the gases which is very light in weight. He has used that type of gases here. Okay, now when he has done some experiment on this. So what are the experiment? One by one we will see them. First of all, he has put one cross like this, no? First thing we can say that like this, one plus sign, plus like thing, or we can say that cross, just like this. So when he placed the cross between these rays, he shows a shadow here. Behind this, he has seen the shadow of this cross. So first thing what struck in his mind is that since it is casting a shadow of this object, it means that it is moving in a straight line. In the same way, we can take the example here. If I will put this pen here, you can see the shadow, no? Here. So in the same way, here he was seeing a shadow of this cross. So what he concluded, that the ray must be traveling in a straight line. Okay. Now number 2. He plays one just like in the childhood, no? we used to use this, no? If you would remember, like this, one paper made up of paper, no? Like this, one substance was there, one object was there, and it is connected with a stick here, and when we run with this, it will move, you know, no? This one, like this substance he has placed here. When he placed this substance here, what he observed, he became shocked with this observation. He saw that this wheel-like object started rotating this way. So what he concluded, since it is rotating, because since light cannot rotate this, so there must be a material particle in these rays which, when hitting this object, it is making them to move, and that object he has given the name electron. Okay. Now next, he became more curious, and he has tried to find out the charge of this this particle. So what he has done, he placed a charge here positive charge, and here it is negative charge here. Sorry, we can say it is negative and here positive, and this was suppose connected here with the battery. Okay, negative, positive, it is in the same way here, negative, here positive. So what he shows, the ray started to move in this direction, in the positive direction. Okay, in the positive direction. So as we all know that positive, they used to what? They used to do what? They used to repel. Negative and positive, they used to attract each other. So this ray, since it is traveling in the positive side direction, the plate where positive plates are placed, so we can say that this ray or the particle which is present in this ray is negatively charged. Okay. Now next, what he has done, he placed one magnet here. He placed one magnet here, one is south, one is north, and he thought that if he assumed like this with his experiment, he assumed that if this charge particle is negatively charged, it will definitely move in the south direction. So when he placed that magnet here, his assumption is confirmed. This light or the has started moving in this direction when he is in the south direction, the south pole region. Okay, so this was all about his experiment. So from his experiment, what you can conclude? Okay, I will give you the notes. In that notes everything will be written, don't need to worry. Okay, now what we can conclude from here? First thing what we can conclude, cathode ray start from the cathode here and move towards the anode. First thing. Okay, now number two, these rays are invisible but causes fluorescent material to glow when hit by them. What I have told you previously, if there is a fluorescent material, any fluorescent material is here, suppose this tube is made up of any fluorescent material, then it will glow. Okay, number two. Number three, in the absence of electric and magnetic field, this one, electric and magnetic field, in the absence of electric and magnetic field, these rays travel in a straight line. Okay, sorry about that. In absence of electric and magnetic field, these rays travel in a straight line. Now next, cathode ray cast a shadow of an object placed in its path. You can see here, this one, it cast a shadow placed in its path and produce a mechanical effect on as small paddle wheel. The paddle wheel which we have used here, it will produce mechanical effect, just like how it will produce mechanical effect just by moving it. Okay, in this direction. Now for fifth one, this ray consists of negatively charged particles. You can see here, negatively charged particles, and are deflected by electric as well as this magnetic field. Okay, now next, about the gases, I have told you in the starting, this characteristics of this rays do not depend on the nature of the electric and nature of the gas. Okay, the characteristics of the cathode ray do not depend on the nature of the electrode or the nature of the gas present in it. Means what? Whatever the gas you will take here, the result will be same. It will not depend on the nature of the gas, or whatever the electrode you will take here, it will not depend on the nature of this electrode. Okay, so this was all about the cathode ray experiment, J.J. Thomson cathode ray experiment. Now what he has done, one more thing, he has tried to find out the charge and the mass of this electrons. Okay, because now we have came to know that it is an electron, so we have given the name electron. So now he tried to find out the mass of this electron. So what he will do, what he has done, he has tried, first of all, you will see here, when he was not using this north pole and south pole and this positive and negative, at that time the ray was traveling in a straight direction. Okay, now when he places positive and negative charge, at that time what he sees, what he saw that the charge was moving, the particle was moving in the positive direction. Now when he explored this only this north and south pole magnet, so at that time you can see that it is moving in a south direction. So now what he has done, he has adjusted this charge of this battery and this magnet in such a way that on the influence of this north pole and south pole magnet and positive and negative charge, this ray is moving in a straight line. Means he has adjusted in such a way that the ray is not deflecting towards positive or not deflecting towards the south. In presence of this electric and magnetic field both, the J.J. Thomson had adjusted the ray in such a way that it is moving in a straight line. Now with this observation he has find out a very important things, what we say that very important observation. What he found out that charge to mass ratio. Okay, so he found that charge to mass ratio, which we denoted by E by M, will be 1.76 into 10 to the power 11 coulomb per kg. Okay, so this was all about the J.J. Thomson cathode ray experiment. Okay, now we will keep up to this. In the next class I will explain you further on this chapter. Okay, thank you.